Hi there, welcome to Young Prof Academy. Today we are going to be discussing a very important topic on chemistry, which is atomic structure. But before we proceed, I want you to understand that we have scientists that their collective work brought about the perfect understanding of atomic structure. So in exams like XSC examination, JAM do ask some series of questions that are pertaining to these sciences. So this is what I brought to you today, so you get familiar with them. So number one is Michael Faraday and David. Michael Faraday and David, the experiment on electronics is what it is what makes us understand that atoms are electrical in nature and they may possibly contain subatomic particles because they are electrical in nature. Number two is Joseph John Thomson, which we all call the J.J. Thomson in the year 1897. Experiment on discharge tube led to the discovery of electron, which we call the cathode ray. And I want you to understand that cathode ray moves according to in line to the normal and can cause cast shadows on an object that is placed along the path. Number two is that cathode rays has what is called kinetic energy. That is energy that can cause motion on objects, kinetic energy, and therefore they can cause the motion of a mechanical paddle that is placed along the path. Number three is that they tend to repel negative charge and attract positive charge. What does that mean? It simply means that cathode rays are negative in nature. They have a negative charge, just like electrons. And number four is that they have a constant charge to mass value of 1.76 times 10⁻11 coulomb per kilogram. So now I want you to understand that because of this, it's now a fact that the electron is a subatomic particle that is found in an atom. Number three is Robert Millikan, 1909, did what is called the oil drop experiment. Because of this oil drop experiment, he was able to discover the charge of an electron, which is a 1.60 times 10⁻19 coulomb. So now I want you to understand that because of these two parameters, it was not very easy to calculate the mass of an electron. You know, you divide 1.60 by 1.76 times 10⁻19 coulomb per kilogram. This we cancel this, of course, and then you do the arithmetic. You'll be having something of 6.6 or so. Let's punch our calculator. Let's be sure of it. When you punch your calculator, you're going to be having 9.11 and it's 10⁻81 kilogram. That's the mass of an electron. So these two guys experiment. This guy, Robert Millikan and Joseph Thomson experiment is what make us understand that the mass of an electron is this. Now, Ernest Rutherford in the year 1911 conducted what's called the gold foil experiment. What was this gold foil experiment all about? This man here was bombarding a gold foil with alpha particles. Alpha particles is just a helium atom, mass number 4, atom number 2, helium atom is an alpha particle. So he was bombarding a gold foil with helium alpha particles, and this alpha particles, of course, is coming from the radioactive source. It can be random. So the experiment might be looking like this. You must shield the radioactive source from the surrounding because it's radioactive and that means it's harmful. So this is just the alpha particles and hitting the gold foil. What is happening is that some we are passing through while some are being deflected back. What it simply means that the atom has what is called a centrally charged body that is positive in nature, which we call the nucleus. So because this nucleus is positive in nature, it will deflect back this positive charge. So it simply means that in 1 out of 8,000 rays is being deflected back, indicating that there's a positive charge body in the center of the nucleus. So that's what this man experiment is all about. Then the next person is Henry Moseley. This Henry Moseley experiment is just very simple, just talking about the atomic number as a fundamental part. It simply means that the proton, that's the number of protons in the nucleus of an atom is just the fundamental particles of an element. Fundamental particles of an element. That's just what Henry Moseley experiment is all about. Then James Chadwick. Now, because if you look at this, the atom that has a nucleus, there's a neutral particle there. There's a neutral body there, so a particle called the neutron. It was James Chadwick experiment that led to the discovery of that neutral body and is in the center of an atom, which is the neutron. So James Chadwick experiment led to the discovery of the neutron in the year 1982. Then Niels Bohr experiment talks about electrons are placed in specific spherical orbits or energy level. You know, when you have your nucleus, then you have the orbit, you know, and I want to understand that each orbit contains electrons. So this next voice is telling us that the orbits, which can also be called energy levels, are places where electrons are placed, and they are placed based on their principal energy level, because each principal energy level has a general formula of 2n squared. So if the principal energy level is 1, if that means when you're having 2 brackets 1 squared, that means you have 2, 1 times 1 is 1, that means 2. So that means the maximum of electron that's going to be found in the first orbit here is 2. N is equal to 2. Yeah, n is equal to 8, as this might be. N is equal to 18 or so. So it will keep on increasing. So and there's a name for each of these shells: K, L, M, and O, P, Q shells. Each of these shells, and they have a maximum number of electrons based on this formula. Based on it. So if the principal energy level is, let's say, 5, if you put 5, it will be 2 bracket 5 square, which is 2 times 25, which is equals to 50. I'm just giving you an instance. So that's just what it's all about. So now, if you look at this whole thing, now you notice that these scientists and the experiment actually led to the discovery of the atomic structure and what it is all about. So I wanted to make sure that you take note of the experiment that these guys did and what the experiment is all about, because the examiners may ask you questions like the oil drop experiment was run by who? The experiment on discharge tube was done by who? So these are the kind of ways that they set the exams. In our next class, I'm going to spread out some sample problems that are related to this topic, so we can see how we can navigate on it. I believe you enjoyed this class, and if you have any question, you can write on the comment section, and make sure you're following me for more topics like this. God bless you as you keep on watching.